Today I'm going to talk to you a little bit about why predictive analytics don't always work, why they fail, and what you can do about that. First, to start off with, just a little bit of background on my company. Some of you would have heard about us, others will not have. Auction.com is the largest real estate marketplace in the world. You can come online to our platform and you can buy and sell real estate. That can be anything from a $6,000 Detroit foreclosure through to a New York office building. We're about 1,000 employees. We're venture backed by Google and a couple of other players. We have one of the world's largest transactions. It wasn't the world's largest transaction recently that's ever been happened online at $96 million for some commercial real estate in Southern California. The quick pitch, those of you in the data world know that the biggest obstacle to doing anything is hiring people. We are hiring, in particular, data scientists and data engineers up here in Northern California and Silicon Valley. If you are interested or you know anyone who is interested, please contact me and reach out. I spend a lot of my time recruiting. It is not always successful, but it is probably the most important part of my job. A little bit about me before we get going. I come from, perhaps not the most traditional background for people in data. I was a Procter & Gamble originally before business school, and then management consultant for my sins for many years afterwards. But for the last kind of 10 years or so, I've been in kind of product management and data, and I've seen the rise and growth of big data and data science. And for the last 5-6 years, I've been going to conferences and I've been speaking at conferences, and I see some great presentations, right? I see, we did this predictive analytics here in marketing, we worked out our lifetime value, we've got a great recommendation engine, we do the predict stuff. And you see and you hear all of these wonderful case examples, and you go away wowed over here. But it's often said that you learn more from your failures than you do from your successes. And today, I'm going to talk to you about my own experiences, what I see out in the marketplace, what I see everything about why these projects fail, and what you can do about that. So let's start off with some statistics. Okay, that was not, technical malfunction there. Hit the wrong button. Okay. 55% of all big data projects fail according to GigaOM. Half of all analytics projects fail according to Gartner. These projects are hard. And if you've done this stuff, you know it's hard. You know sometimes it's really hard. And sometimes they really go down in flames in quite spectacular ways within organizations. And today, I've kind of isolated what I think 5 of the key reasons these projects fail specifically, and what you can do, not necessarily to completely avoid failure, but to give yourself a better shot, a better chance at making your project successful. So let's start off. The first and fundamental is probably the most obvious, but I'd be remiss if I didn't mention it. And that is, we didn't eat our big project greens. Okay, what are big project greens? These are the stuff that we have been told about in technology, in IT, in large-scale project management since the dawn of time, right? And they equally as well apply to all the root cause projects that fail in data. Often people say, well, big data projects are special, predictive analytics projects are special. And yes, they absolutely have their nuances. But I'd say that probably half of them failed for all the traditional reasons big projects failed. We didn't have sponsorship, right? Absolute number one reason a lot of projects fail. Yeah, no sponsorship from some key line exec, some key business exec, some key technology exec. Now, it's worth pointing out that in the predictive analytics world, the big data world, this is often quite complicated because you might need a line sponsor, you might need a technology sponsor, you might need a marketing sponsor as well. There's a lot of different people you're bringing together in some of these projects, which make this even more of a challenge than it usually is. Clear objective, right? You know, a clear objective is not, we are going to play around with Hadoop for a bit and see if it's good for us, right? You know, a clear objective that is outlined in business terms, like we are looking to improve our marketing mix optimization by X%. Organization and people. You know, I alluded to this at the start of sponsorship. It's not always clear the roles and responsibilities in big data and predictive analytics. Sometimes it's under technology, sometimes it's under line, sometimes it's under marketing, sometimes engineers are under one part, sometimes data scientists are under another part. And there's thought around how do we align people and incentives properly together. Again, another key part. Again, a classic reason your projects fail. And project management, right? I mean, just like basic risk management, scope management, are we working towards meeting our objective? I'm not going to dwell on all of these big project agreements because you guys have heard this and you're saying, yeah, Sheridan, I know that. But don't ignore this stuff, right? This is the stuff we've been taught from time immemorial, and it applies just as well, if not more so, to our big data and analytics projects. Okay. Number 2 reason. We didn't ask the right question. What do I mean by this? There's a classic case, if you've done microeconomics and you've done information economics, there's a really, really important statement, and that is information is worthless unless it has the power to change a decision. And let me give you 2 key examples of what I mean by this. I'll give you a personal example and I'll give you a business example. Business example, many years, 10 years ago. In an organization, we're talking about, do we shut down a business unit? And we've hired the management consultants. And it's the final meeting. And there's 8 of us. And the management consultants, they come into the conference room. And boy, it's not a deck, it's a binder. And you know you're in for a doozy of a meeting with this. You know, you're in 1 hour, 2 hours, somebody please shoot me. Charts, color, graphics, all over the place, up the wazoo. And then there it was on, I don't know, page 384. Slide, chart, headline of chart, red, headline of slide. This business unit has never been profitable and never will be. Okay, there on that one page, we had the information we needed to make a decision. 382 pages of context that we didn't need over there. A bunch of worthless information. Let me give you a personal example as well. And those of you who've got spouses will know this. I'm driving along, and we're driving along, and we've got to make a decision. I say to my wife, I say to her, honey, shall I take the freeway or shall I take the side streets? And she thinks about it for a little bit and she says, I think we should take the side streets, Sheridan. And I come back and say, nah, I think I'll carry on the freeway, right? And what did I just do there? I asked for a piece of worthless information because unless I was just being obtuse, I'd already made a decision that I was going to do something. And regardless of the information I got back, I was going to make the same decision. Very, very key, important corollary in analytics and data science. So, the corollary to this, the most important question we have in predictive analytics, the most important question we must ask ourselves is, what are the decisions that will be made as a result of the predictions? That is the most important question. And those decisions can be made internally by your customers, by your partners, whatever your product or service is for over there. But it is the most important question. Let me give you some examples of why we set up badly. Let me give you an example. Who here has ever done lifetime value calculations? Was asked, what's the lifetime value of our customer? 1, 2, couple over there. What's my predicted lifetime value, the lifetime value? That is a wrong question. It is absolutely the wrong question for a data science group to be asking. And if you ask that question and you start with that as your premise for what you're going to do, you are going to go wrong. And why are you going to go wrong? Because ultimately, what's my predictive lifetime value is not around a decision, right? It's around an arbitrary number. And you've got to focus your key problem statement around a decision. Now, there are lots of uses for lifetime value in combination with other things. But if you phrase it as, how should I allocate my marketing mix next month? A very, very specific question focused on key decision points, then that is the question you should be answering. Because if you go down that route, you'll think about, well, what are my marketing costs? How does my attribution model work? And you will focus on answering that question as opposed to some esoteric number at the top. So key, make sure we're asking the right question. We didn't understand the limits to predictive analytics, right? I think this is a really, really important point. And we spend a lot of time kind of going through and thinking predictive analytics is going to solve world hunger. It's going to be great for organizations. It's going to add 20% to our revenue and so on. But predictive analytics has its limits. And it's really, really important we understand where those limits are. The first, which is a really classic example, is the dirty little secret of predictive analytics. Not 100% true, but mostly true, is that we make predictions based on the past, right? So, and the past is not always a good predictor of the future, right? And so that's a key limitation. What might happen? Well, hey, this curve, by the way, is a lifetime value, a cumulative revenue curve, right? We may have a new product intro. We may have a fantastic new business model. It's great, right? The curve we predicted on our revenue stream, much, much higher than we thought. But equally, the reverse may be true. We may have a massive market or regulatory change that goes on over here, right? And so when you think about this situation, you kind of run into the past is not always a good predictor. And let me give you an example from my own situation where we ran into a problem. I was working at a games company, and we were doing some, fantastic lifetime value calculations. We'd got lifetime value calculations by cohort, by source, by lots of different things, predicting all sorts of numbers, curves, up the wazoo, up to months and months. And it was predicated on a fact that we were going to carry on using the same payment provider we had. This was Facebook Games. In January 2011, Facebook made a monumental business decision for us. They insisted that we use their payments platform. All of a sudden, the margin we were paying on payments, which was roughly 5% of revenue, jumped to 30% of revenue. You imagine that, a 25% hit straight to your bottom line as a result of a change. Now, none of our models took that into account. We didn't say this, right? We had some inkling, perhaps it was possible. And so we ran into so none of those lifetime value models are coming in the remotest bit true because of this huge change that we've had going forward for us over here. If you remember one thing, shifts happen, right? So your curve and your predictions may happen, and they may happen for things well outside your control and things that you cannot inherently predict or build into your traditional predictive models. So what do we do about this? The first thing I'd say is it's okay to use different models, right? I mean, we all think we've got to use, the latest random forest trees, whatever analytic model and predictive model is the flavor. It's okay to use different models. Crowdsourcing. I can't go into details on this, but it's something we're playing around with a lot, around the wisdom of crowds, around what they know and what they don't know to help improve your prediction levels. Scenario analysis. Those of you who are familiar with the Cold War, right, will remember that scenario analysis was kind of came out of that, and it's really interesting because let's take the Cold War example. You can't just make kind of a nice prediction and come out with an easy decision-making process. Let me give you an example from the Cold War. Let's assume it's, the Bay of Pigs, 1963. I don't know. Forgive me if I got that day wrong. And the probability of a nuclear strike by the Soviet Union is 10%, and we estimate 100 million people will be killed. And there's a 90% chance that nothing will happen, right? 2 scenarios. So we can take the expected number of people who die, which is 10 million, right? That is a meaningless number, right? I'm going to run a mathematical model and a predictive model against that, and I've come up with a meaningless number because we know for sure that situation won't happen. So planning around 10 million people dying is a terrible prediction because we even know 100 million or no million die. Scenario analysis, if you've not used it, if you've not thought about it, look it up. A lot of great literature was built on this in the 60s and around that time. Equally, the corollary to this game theory, right? How do we think about how our customers will react to various entrants and predict that in ways, right? We can kind of try and model and predict our customers, but game theory is another great way to be looking at stuff. And quite frankly, sometimes there's simple methods, right? You don't need to, sometimes that linear chart, that straight chart may be the best option for you. This is another crazy thing. We may not want our predictions to be right? If you look at predictive analytics people, they'll often measure the success of their model on how accurate it is, right? We say, we check, and we understand how, is our model really, really accurate? But is that truly what we want to achieve from a business sense? Let me give you an example we run into. Revenue predictions, right? If all we can do with revenue predictions is perfectly predict what our revenue is going to be in 1 quarter, 2 quarters, 1 year, 18 months out, whatever time period we choose to do, then something's gone wrong here, right? Because we want to be beating that curve. We want to be beating that prediction all the time. We don't want to be hitting that prediction. I ran into the same thing, interestingly, at a games company as well. We were predicting the success of our products in beta. We'd have an early beta, and we'd have a survey. And we found out we could perfectly predict whether this was going to be an A title, a B title, or a C title from what happened in beta. But that's a problem, right? Because we continue to be able to perfectly predict this stuff. We weren't able to actually change anything from beta to going live, right? So the fact that our model was a success actually didn't matter because the underlying business thing was a failure. We don't understand a monster called statistics. One of the things I love about modern big data and predictive analytics is we've got a broad church in here, right? Beforehand, it's kind of people in analytics, a PhD in statistics or something like that. But there's lots of people now who come from an operations research background. One of my best data scientists comes from an economics background. And we have a broad church, but that doesn't mean we can ignore basic and fundamental statistical principles, and we fall into this problem all the time. The first one is correlation does not mean causation. And boy, we've learned this from day one. Anybody who's taken a business statistics class, a business statistics class, a business analyst class, no. Correlation does not mean causation. We repeat it. It's like a new age tantric chant. Correlation does not equal causation. Correlation does not equal causation. Correlation does not equal causation. But do we actually follow through on this when push comes to shove? And this is the key thing, and especially in the world we've got into with high levels of processing and our ability to process so many data. If you look at enough random data, you will find matches. It is absolutely guaranteed you will find correlation. And what we have now is the ability to match up thousands of different factors with thousands of other different factors. And I promise you, in any random set of data, you will find patterns. No matter what, you could randomly generate them and you will find patterns. Let's take a look at, let's take a look at this, right? This is the divorce rate in Maine plotted against the per capita consumption of margarine, right? Let's look at that. That is pretty damned good, isn't it? Right? So we're kind of like, if you looked at that, you say, "Whoa, we found a really, really good correlation." Now, perhaps one of you out there can find a great reason and rationale about why these may be correlated to each other, or why they may be caused by each other, or what is causing the other over here. I struggle over there, but if we look through random sets of data, we will find patterns and matches over there. Probably the most seminal piece that I have seen on data science actually came in the recent year has actually came from The Economist. And it's an article, I think it was around the earlier first quarter of this year. You can look it up. It's called False Hope. And it's primarily around the financial services industry, who look at tons and tons of data. And it basically comes through with the same conclusion, is that we're running all of these correlations in the financial service industry to try and get some edge in your trading strategies, right? And because we're running it, we're always finding some pattern, but that pattern can often be caused by randomness. It's a one-page article, False Hope. I highly encourage you to read it. Variance kills. Question, who here does predictive analytics or some form of predictive analytics in the organization? 1, 2, 3, probably half the audience. Do you guys always quote the variance in your model when you come up with it? Who quotes the variance and is always conscious of the variance in anything they present? Nope. Okay, big no from people. Variance can kill you, right? It's no use saying, the expected, we're expecting a revenue, our predictive model says, we're going to be at $10.8 million in revenue. But hey, guess what? It's plus or minus 9 million, right? So within a 95% range. Key factor here, if you're quoting a predictive model, you should always be thinking about ranges and variance. Let me give you this example. It's from the gaming industry. It's not exact numbers. We have Belgium and we have Holland over here. We have 100 users in each. We have 10 paying users in each cohort. We have an average revenue per user of $5.80 in Belgium, and we have an average revenue per user of $14.80 in Holland. 5 times as much. Holland, Dutch customers make us 5 times as much as Belgian customers. So what's this difference down to? Oops. One data point. Somebody made a huge purchase in Holland, and that skewed our data set enormously. We have a standard deviation of $21 there, a standard deviation of $101 there. And so if we start to make marketing decisions on this, we start to do something, we've totally missed something, because this data, like within the bounds of confidence, doesn't make any sense. And by the way, why did we not put Belgium and Holland together to get a larger sample size? If you know Europe, and forgive me if there are Dutch and Belgian people here, but the difference between Belgium and Holland in like demographics and psychographics is really not that different, right? They're bang next door to each other. They have similar GDPs, similar sets of demographics. And so we've got to think about our sets of cohorts and how the detail we get to our predictive model and the variance that implies. Yeah, sure, we want to cut our predictive model every which way, but if we do that in such a way that actually kills the variance in our underlying thing, we've made a horrible, horrible mistake. Sure, you can. Yeah, I think there's a case. So the question to the audience is, do you look at outliers? And I think that's a very, very good question. I think there's a couple of things that we think about for us. The first, in the games industry, we talked a lot about, do we take out outliers from samples, right? The first is that actually these whales make the majority of our purchase dollars in the games industry. So you can take out the outliers, but hey, guess what, right? Your revenue, they contribute the most amount of revenue, right? And so you have to be very, very careful when you take out outliers, that they are generally kind of aberrations as opposed to the genuine patterns of your thing. It's definitely a trade-off, right? And you have to think about it, right? I could take out my outlier here, but hey, I also want to be looking and understanding, how do I get that $1,000 customer? So if I don't look at that within a larger sample set, I'm going to miss that. Your sample may be bad, right? This, to me, after the correlation equals causation, is the other key problem we run into, right? Picking a bias sample, we look at survey data, right? Survey data often has the inherent bias that people who like taking surveys take surveys, right? You've got a bias sample straight off. We often have biased samples of our incoming traffic. Hey, if we've all of a sudden decided we've got a marketing switch to China from the US, so we're going to bring in tons of Chinese customers instead of something American customers, and we're making the assumption set that all of our models, everything still holds about that set, well, that's a bad assumption set, right? Because all of a sudden the sample in which we've changed has changed rapidly. And you only need to see like the average revenue per user of a customer from China versus the US to understand why that may be a bad thing. So it's key you understand the sample set that's coming in, how it's biased, and how that sample set has changed. So what are some of the potential solutions here? The first is kind of like the obvious. I think it's really important for any data science group to have at least one really hardcore statistician type within them, right? I think you need that. Do you need to have them all? No, absolutely not. But you need, I think, somebody who's got a hardcore statistics background who can really hold your conclusions through to account and keep you honest. Out of sample tests, this is really, really important. I mean, when we build our models, we build, like some of our predictive models, we'll build it on an old sample set and then we'll test it against a new sample in the current month. We'll test it on an out of sample set. And we'll continuously do that. We'll continuously test the model once it's in production to see if things actually hold up or we manage to pick factors which were just random aberrations. And the last thing I said to you is, like, when you're displaying these numbers, when you're talking about these numbers, certainly internally, make sure you're displaying variance, confidence ranges over here. Don't just kind of show and look at a prediction, but also what the variance is with every model that you show out there. And of course, as I said, understand the sample. The fifth and final point here is we didn't build the last mile, right? And those of you who are familiar with the telecoms industry will know what I mean by the last mile. The last mile is from, you know, the sub box to get to your house, and it's typically the most expensive and the most difficult piece of the network to build. And we often miss this in predictive analytics. So we've got the model, it's great, right? We've got some great clusterings, we've got a correlation, fantastic, looks perfect. What do we do now? And for us, and I think this is really important, we don't think of, you know, I started off talking about a lot of project management, but we don't think of predictive analytics work and the work we do in big data as projects. What we think about is how do we turn them into a product or a service, and that product and service that actually gets used. So when we think about that, we think about a continuous improvement. We measure, right? We continuously have the out of sample test. We data, we learn, we build, we code. We continuously use this as a service, not a one-time project. Web services. Everything we build from predictive analytics, we give as an API REST as service, right? So that it's not tied in or built into the one system that you all of a sudden decide to ditch 2 months later for another reason, right? It can be integrated internally, it can be integrated externally, it can be integrated with your website, with your partners, wherever you want it to be. So it's agnostic to the kind of root system that it gets integrated into. And you know, product methodology, we run our services in our data science and data products group just as a regular engineering team. We have resource planning, we have sprints and scrums, tickets, we have an ongoing roadmap, we measure and we constantly feed back on all of these pieces over here. And I think that's an important part because, as we talked earlier, we need to get these incorporated into the grain, into the mantle of whatever we're doing within the organization. So let me just wrap on a couple of points, and I think we're going to have, you know, a few minutes left over for some questions over here as well, with some final thoughts. The first is, if you only I think I had a professor who said that people can only remember one thing from your talk, right? And so I've cheated and I've got 2 things. So if you only remember 2 things from this talk, I think focus on the decisions you want to change, right? Make sure that at the very start of whatever product effort you're starting off with, you know the decisions you want to influence and you know the outcomes you actually want to come up with. And the second piece over here is, don't get hung up on the technology. You know, particular models, you can get very hung up on perfecting that data, perfecting the model, perfecting the technology. I look back and I look at the technology decisions that I've made over the last 5 or 6 years, right? And I have technology vendors. My deepest apologies to any technology vendors for what I'm about to say here. But I can honestly say that not one of the technology decisions I've made over the last 5 or 6 years have had any significant impact one way or another, right? And you hum and ha. I hear companies who spend 6 months working out whether Cloudera or Hortonworks is better. Like, I looked at it and said, we made a decision in a week, right? So and quite frankly, could have gone the other way, and I'm sure it would have been fine as well. Wasn't something we needed to sweat. And you've got to be careful. A lot of times we sweat these technology decisions. We think they're going to be the be-all and end-all of why we succeed and fail, and very often they don't make a damn bit of difference. And on that, folk, I will wrap up. I've got, I think, about 5 minutes here for questions, and I'm happy to take them as many questions. I am running out because I have to catch a flight in 2 hours. But by all means, email me, send me a LinkedIn or whatever you want to do if you have further questions or you'd prefer to do your question in private. Thank you very much.